Hello guys, today we're going to talk about dilations, which is the one transformation we have not spoken about. It is not an isometry, by the way, but what a dilation is it's a transformation that makes an image similar to its pre-image, meaning that either stretches or shrinks the figure by a scale factor k about some point. So again, since the size changes, make sure we are aware that because of that it is not an isometry. Okay, but notice that I do say here that the image is similar. Okay, so its size changes but its shape does not. Okay, and we have two situations here. If our scale factor is greater than 1, then our image will be enlarged. Of course, it'll be a stretch. And if it's between 0 and 1, it's going to be a shrink. The size is going to be reduced. And we're going to talk about what happens if the scale factor is negative as well in a second. So let's look at how we produce a dilation. Okay, so you see here that every point on the image lies on a line that connects the center of dilation to that corresponding point on the pre-image. Okay, and so the distance is changed by the same scale factor that the object is. And this may seem a little wordy, but let's look at an example to make some sense of it. Okay, so this figure here, you can see we want to dilate by a scale factor of 1/2. So the first thing we would do, according to what we just read there, was we would draw lines from the center of dilation through each of the points, in this case the vertices, but it should be every point. And let me clean that up. Okay, so we have these lines drawn, and our goal is to actually, if I had a ruler, we would measure this distance, and then my new point C prime would be exactly, since my scale factor is half, exactly halfway between the center and C. That would be my C prime. And D prime would be exactly halfway to D, and B prime would be exactly halfway to B. And this was pretty rough estimates for me. Let me show you the exact diagram. And here would be our actual image, B prime, C prime, D prime. And so again, the idea here is this distance is exactly half of the distance from the original point, the same thing from C prime compared to C, and the same from D prime compared to D. And not only is the distance half, but also the size. So we know that like D prime, B prime would be exactly half the length of DB. And same with all of these sides. So this side connecting D prime to C prime is exactly half of DC, and C prime to B prime is exactly half of CB. So what you see here is we have a situation where not only is the size of the image half compared to the pre-image, but also its distance is half. Let's look at another couple examples to make the point. Okay, in this second example we're asked to dilate, I'm using the same pre-image, we're asked to dilate by a scale factor of 2 instead of a scale factor of 1/2. So again, we're going to draw our lines and extend them, but instead of measuring the distance from each point, like from B to the center, and then taking half, I want to make my new point B prime be twice as far away. Okay, so let's look at where those points would land. I know it's hard for me to fit the whole picture in here, but the idea is our center, you can see down here, the distance from B to the center, B prime to the center is exactly twice as long, right? So from B prime to the center equals 2 times from B to the center. And then the same would be true of C and C prime, and D prime. We can see that all these lengths are doubled, and along the same lines, again, the size of the triangle itself, this side is twice the length of this one. C prime, D prime is exactly twice the length of CD, and so on. So the image is becoming twice as large, and it's becoming twice as far away. Let's take a look at what happens if we have a negative scale factor. Okay, so here we're asked to dilate by a scale factor of -1/2. So the first thing I'm going to do, of course, is draw my lines again. Okay, so here are my lines, and now instead of, I still want to go half the distance, right? So like let's say I wanted to transform point A. Whatever this distance is, I would want to go half as far away from point P, but this negative, what it makes me do is go in the opposite direction. So I would take this length, but go in this direction, and A prime would actually land over here on the other side of my center of dilation. Same thing would happen with B. I would find my distance, take exactly half, but go this new length, this half length, in the opposite direction, and B prime would be over here. Okay, and so on. I would continue this. I would take the length, go half that distance, but in the other direction, and continue. So let me kind of clean it up and show you where that image would be. Okay, so you can see now that I got it cleaned up that our figure is still half the distance, right? PB prime is still half of what PB would be, right, compared to that length, right? Same as all the others, right? PA prime is half of PA, and so on. My side lengths are still half, right? A prime D prime is still exactly half of AD, and I could keep doing that with all of them, right? Like C prime D prime is exactly half of CD, but it's in the opposite direction, and so because of that, it's in a different location, which is a little bit rare. I also want to point out one thing real quickly. Notice that all of these dilations, all line segments are parallel on the image to the ones on the pre-image, right? So corresponding line segments are parallel to each other. Anytime you've undergone a dilation. So notice here, right, like AB is going the same direction as A prime, B prime, and so on. This is true for all of these. Let's take a look even at some of the other pictures real quickly. If I go back and look at a couple of these things, right, going back to this picture, notice that B prime, D prime is going in the same direction as BD, right? C prime, D prime is the same direction. You can see that these are parallel. I'm going to even go back to the first one as well. Even here you see that, right, each of these lines are parallel to the original one. So what we have here is some good stuff going on. We know that every line segment is parallel to each other, right? Its length is multiplied by that scale factor, is multiplied by K, and its distance from the center is multiplied by K. So that's the big keys to dilation. But before I finish, let's take a look at some things on the coordinate plane. Okay, so obviously like the other ones, we do want to be able to talk about on the coordinate plane. So I'm still going to dilate around the center, so that my center of dilation is going to be, I should say about the origin, not about the center. Let's say the origin is our center of dilation. I want to dilate by a scale factor of 3/4. This means, again, that I should find the distance. In this case, the distance to A is 4, right? So like OA equal to 4. That means O prime A prime would have to be 3/4 of that, which is 3. So my new point lies on this line at 3 units away. For point C, if I draw a straight line, notice my slope is -1, so that's going to help me figure out where it should land. And I want to count, I can see like 1, 2, 3, it's going 4 diagonal units, so I can put C prime right here. And the same is going to happen over here with point B, right? If I drew that line, I want to be 3/4 of that length. And again, this is 1, 2, 3, 4. So 3/4 of that is 3. And so my new image, A prime, B prime, C prime, is going to fit right inside here. And that's only because our center of dilation was inside of my triangle, right? But you can see this length is 3/4 of its original one, and my new image is 3/4 the total size. Let's take a look at this one more. Okay, for this one, I'm dilating about the origin by a half. So again, I'm going to connect these lines and go half the distance. So this was over 4 and up 4 to get to A, so I'm going to go up 2 over 2. To get up to point B here, if I were to draw a straight line, you can see I'm going up 1, 2, 3, 4, 5, 6, 7, 8 and over 4, so I need to go up 4 and over 2. And there's B. C is up, let's see, we're at the point 6 comma 4, so my new point is going to be half of that, so over 3 and up 2. And D, of course, is over here at 6, 6, so I need to be at 3, 3. Okay, so here's my new image. It's easy to see that it's half the size, right? This length is 2, now it's 1, 2 becomes 1, 4 became 2. So we can see that this similar figure still exists, and maybe you picked up on what the rule should be as well, right? Notice that if I'm going through a dilation, xy is becoming my scale factor times the coordinates. And this is the rule anytime we're dilating around the origin, okay, by scale factor k. So we're going to play with this in class tomorrow, and hopefully this made some sense.